Working with large projects in DVT IDE, for example, doing integration work at SoC level, can be just as smooth and swift as working with a single IP. After all, you typically work only within a small part of the code, while design files or verification IPs are mostly unchanged. Compiling everything from scratch leads to a lengthy build time, which in turn impacts both the initial bring-up and subsequent full builds. Precompiling fragments of your project is key to bringing down build time. The build configuration of SoCs is usually split into several DVT init sections, each corresponding to a simulator invocation in a multi-step compilation flow and typically mapped to distinct worklibs. To see immediate benefit from DVT precompilation, simply add to your build configuration the DVT precompiled db auto directive, followed by a save location. The very first time you build a project, each DVT init section gets saved as a precompiled database. Subsequent builds will load the precompiled fragments from disk instead of reanalyzing the source files, leading to a significantly improved build time. Moreover, DVT automatically keeps the precompiled databases up to date if source code changed since the last build. It is recommended to disable automatic precompilation for those init sections containing files that are constantly modified. For example, the test benchtop, where you are integrating other IPs. You can either do this by worklib name or per init section. Now, the next step up is a fully blown integration of precompilation into your flows. Prepare precompiled artifacts in advance, perhaps in your CI/CD pipeline, in order to get speed-ups from the very first build. First, you have to create build configuration files for the project fragments you decide to precompile, typically each containing one or more DVT init sections, and the precompiled db save directive, specifying the location where the database shall be stored after build. Next, refactor the project build configuration to first load the saved databases, instead of explicitly specifying the files for compilation. The files you are actively working on must be specified last in separate init sections. Of course, you will most likely create and update the precompiled databases in batch mode using DVT build.sh as part of a fully automated precompilation process, and deploy the resulting artifacts in a shared location where they can be referenced by teams across the entire organization. You can seamlessly browse and navigate around the project, for example in DVT views or diagrams, even if precompiled source files are not available at load time. DVT will automatically pick up the source files if they're exactly in the same location as when precompilation was performed. If not, for example when files are checked out to a user-specific location from a version control system, you can use this dedicated directive to remap their paths. Ultimately, for maximum benefit, you can combine the presented approaches and tune to the specifics of your project. The user guide provides comprehensive information, including recommended best practices and a configuration skeleton to build upon.